Hello, this is Britt Caswell with another example video. In this video, I'm covering Example 2 from Section 2-5 in the SavvasRealize Algebra 2 textbook. So the goal of this video is to understand the process of completing the square. Alright, now completing the square is a method for solving quadratics in which we are trying to create a perfect square trinomial. Okay, so that's why example 1 was a little bit weird. So let's talk about this expression, x squared plus bx. Okay, and I'm going to try to draw this as an area model to help you to make sense of this. So first I need to draw x squared. Okay, so if I draw a square with the sides x by x, if I go to find the area of this middle box, that would be x squared. Okay. So now if I want to find an area model to show bx, right? I already have a side length x. So I can go out b number of units. I don't know what that'll look like, but pretend like there's a rectangle here that's b units long. If I go to find the area of this box, I know that it's x units tall by b units wide. So the area here is bx. Now here's what I'm going to do, okay? I'm going to be taking an X-Acto knife, and I'm going to be cutting this bx perfectly in half. Okay, so I'm going to call it bx over 2. Alright, and I'm going to keep one half here, and then I'm going to take the other half and snap it here at the bottom. So let's take a look at what that looks like. I shouldn't have drawn the dotted line. We'll go a little faster. Okay, so I'm taking that B area model, and I'm making half of it. It's about that wide. So remember, this is B over 2. Now the other half of it, I said I would put down here at the bottom. Alright, so this is b over 2 x, and this is b over 2 x. Alright, now this process is called completing the square, right? Do I have a square here? I mean, I have close to a square, right? I have this side length, which is x plus b over 2. And I have this side length, which is x plus b over 2. And if I multiply them together, that would give me this black square. But I'm missing a little portion of it. Do you see how this little corner is not there? Right here, this is what I'm coloring in probably too dark orange. Now we can find the area of that little square, right? It has a length of b over 2, and it has a width of b over 2. So if I multiply b over 2 times b over 2, I'd get b over 2 squared. Okay, so the process of completing the square is we take this expression and we add this little teeny tiny piece onto it, and suddenly it works as this expression here. It turns into a perfect square trinomial. So the way that that trinomial would look, if I wanted to write this in this form, I would have the sides of this big square squared, right? So I would say x plus b over 2 and that has been squared. Now, in the process of squaring that, we had to add on this little orange piece, didn't we? But this part here containing this little orange piece isn't the same thing as just the red and the blue piece. So what we have to do is, now that we have incorporated that orange piece here, we have to take it away, because we need it to be an equivalent statement. It has to match that first statement of x squared plus bx. Right? That is the mathematical process, and that's why it works. Now, when I show it to kids, I tend to do it a little more formulaically. Okay, so what I'm going to do is I'm going to show you kind of a process. So the stuff that I'm going to write in black here will always be the same every single time. Right? Now understand, this only works if your x squared has a 1 in front of it. So if you have a number in front of x squared, you need to divide by that number to get rid of it. So here's what I do. I have my parentheses, I have a square, and then I'm going to have like a minus. Okay, and we'll have some blanks here. So this is what it looks like. So I'm always going to drop down my variable. In this case, it's an x. And I'm always going to drop down that first sign, which is a plus. And then I drop down my c, which is 5. Now this first blank, to fill in the first blank, I should use blue on that, my bad. This first blank is always going to be whatever b is divided by 2. So here, if I take 8 and divide it by 2, I get 4. And then remember, just like up above, we had to subtract b over 2 squared. So I'm going to take that 4, because that's b over 2, and I'm going to square it, which is 16. Alright, so then I do what I call the cleanup stage. So notice they're asking us for it to say x plus p squared equals q. So I need to get to the equals q part. So here I have x plus 4 squared, which is good. And I'm going to combine my like terms here. So 5 minus 16 is negative 11. And then to move it over to the other side, I'm going to add that 11. So I get x plus 4 squared is equal to 11. Let's go ahead and try another one. Okay, so again, I'm going to set up my parentheses squared, have a subtraction of a blank equal to 0. So I drop down my x, I drop down my first sign, I drop down my c. Now in this first blank, I need to do b over 2. So here I have 6 divided by 2 is 3. And then once I have that, I square it to get my other blank. So 3 squared is 9. And then I collect my like terms. So I keep my parentheses, and then negative 11 minus 9 is negative 20. And then they want it to be something squared equals to q. So I'm going to add the 20 to the other side of the equal sign. So here I get x minus 3 squared equals 20. And there you have it. That is how we complete the square and why we complete the square. Until next time.